Okay, Isabel, I'm just going to go over what we talked about and more. So here's the questions, and just grabbing the textbook. This is a useful chart as well. I might send it to you. Just shows you the standard um, items. But here's the question we did. So that's not the question we did. This was it here. It was the sunny days, and it's very complicated. That's the hardest question for sure. Okay. As soon as I get going here. All right. And the first thing I told you to do is understand the coast curve. So start with your very basic parent curve. And we knew right away that coast curves start up high here, go down, hit a bottom, go up, and reach a peak again. We also saw that this one was stretched by 28 above, so 28 amplitude. That's always going to give you amplitude, and that's always going to give you the y-axis, or the axle. So we also saw that this is raised by 10. So right away, we could start off by saying y, and yeah, that's a little small. So I'm just going to try to get my act together here. Right away, we could start off by saying y is equal, and yeah, I know they gave it to us, but we just want to understand what's going on. Right away, if they just gave you that, you could say y is equal to 28 cos x, and figure out what cos x is, plus 10. Now, what does the minus do? The minus flips it in the x-axis. That's because it's affecting a y value. So these are all the y values up here. Like anything above the x is positive y. Anything below the x is negative y. So when we slam them negative here, you're essentially flipping all those. And the actual graph starts down here, goes up, hits a peak, comes down, and hits the bottom. And it starts in January. Now this makes sense because January is the coldest, and over here December is the coldest, and then summer is going to be the hottest. And so you got to apply a certain level of logic. And there, what's interesting about this is you can determine the temperature based on the day. So normally, if I told you it was day 100, you'd put 100 here, you'd multiply by 2, divided by 365. Actually, you take 100 divided by 365 to get a percentage of the year we're at. Then you multiply it by 2 pi to get the angle. Then you take a cos of that. Then you multiply by minus 28. Then you add 10, and you would get the temperature from that. But in this case, they're reversing us. They're giving us the temperature, so we put that on this side of the equation. And they're asking us to figure out which day of the week it is. All right, so just so I do this to understand it's probably going to fall, because the hottest is 38 here, which we figured out was 28 above the axis, and therefore it's going to fall somewhere in between some days here, which means I would start off with the equation. I would just take the equation like this, and I would make it equal to 32. So 32 is equal to that. But step number one, so that I want you to write down, step number one is this. Remove the angle. Replace it with x. Remove the angle, replace it with x. This just helps you to clarify, focus on the angle, and not get too convoluted on all the transformations that are being done to the angle. So there's the angle. And in the middle, you just chop it out and replace it with x, or theta, or whatever tells you that we're looking for an angle. Just remember there's almost always two angles, which makes sense, because you can see we crossed the sine curve twice here. We would only cross the sine curve once if we were looking at a temperature of 38. We could just instantly say that's the only day. But anything lower than 38 and above minus 18 is going to cross the sine curve in two spots. So this is our first step. So all we have to do is solve for x. So we subtract 10, and we get 22 is equal to minus 28 cos x. Then we divide by 28, so it's 22 divided by 28 is equal to cos x. So we're going to get a value here, which we did, and try to keep as many decimals as you can. And remember that you do 22 divided by 28 and then hit the plus minus sign, then equal. So I'm just going to keep them all. Okay? So we're dealing with this. Now, the other thing I want to do is I want to forget the minus sign because that's going to give me 140 whatever degrees. And I want to just work with the actual value and remember that it's minus. It's minus. So now that I have solved that, I'm going to find step 2. Find the two angles, terminal angles, or principal angles, based on the acute angle that I find from inversing from the acute angle that I find. So if I take an inverse of this, I get this angle. Trigonometry inverse cosine equals. So I get this. I did it wrong. So I didn't quite do it properly. So I'll just go back to whatever, hit that. I'll take 22 divided by 28. I'm going to get a negative number. I'm going to get rid of that number, and I'm going to inverse cosine. And I'm going to get, again, the wrong angle. Try it again. So I'm going to get 22 divided by 28. I'm just going to leave it positive. I'm going to take my trigonometry, inverse cos equals. I think I did not do that correctly because I know 22 divided by 28 gives me a pretty large cos, which should be around, well, it should be quite a bit. So I'm going to go to trigonometry here. Second, inverse cos that. Oh, there we go. I don't know why it didn't do it that the first time. 38.213. So I'm going to just take a copy of it. And I'm going to say my acute angle is that. So I've discovered my acute angle. Now we go back to remembering that cos x is negative. So that would be step 3. Step 2, based on the positive, based on the number, not the positive or negative. So you just do the basic number. Then step 3 would be, recognize in this case, cos is negative. Figure out the quadrants. Well, according to CAST, cos is positive here and positive here. Therefore, we're dealing with quadrant 2 and quadrant 3, and it means the acute angle that we're talking about is that. So to figure out the principal angle, I'm going to take 180 and subtract that, and 180 and add that. Now notice I'm working in degrees. You can set your calculator right away to work in radians. So there is a button. So right away, if I hit clear a few times, and I go back to my 22 divided by 28, and hit equal, and click this degree and change it to radians. Now if I do inverse cosine rather, it's going to give me, it did it again. Oh, yeah, it was in radians. That's what's going on. So 22 divided by 28 is equal to that. And then if I make sure I'm on radians, right, and go to trig inverse cos. So I get 0.666 radians. So we're just going to remember that and see if we do indeed get 0.6666 radians. Oh, that's for the acute angle. So now I'd have to take pi and subtract that, and pi and add that. So either way works. Just remember that that's a numeric of the angles. You could convert it to pi by dividing by pi, and you'll get x number of pi's. Then you could subtract it. However, you can also work with degrees. Ask your teacher which he prefers to see. So now we're talking about 180 minus that. So principal angle 1 is equal to 180 minus 38.213210. And principal angle 2 is 180 plus that, which is equal to 218. 0.21321, we'll say 1. We'll say 1 here. So here would be 141.897.899, something like that. I think I got the first one wrong. Yeah, there we go, something like that. I'm going to just wing it and say that's what it is. 1 turns into 0, 1 turns into 0, 2 turns into 1, 3, that should be a 2. That turns into 3, that brings over the 1, don't need that, and then I think it's that. Yeah, so that would be it there, I think. No, I got it all wrong. So that would be 1, so that's 9, and that means I need an 8 there, which means I need a 7 there, which means I need a 6 there, which means I need a 8 there, which means I need a 7 there. Oh, 8 there. There, that should be it. Nope, 7. So there you go. That's the principal angle number 1, and that's principal angle number 2. So now that you have that, you need to convert it to radians, and you could have also done it. Originally, remember I said it was 0.666 radians. You can also take the 0.66, convert it to pi radians, and add it to 1 pi, and subtract it from 1 pi, which is the same thing as this. So if I wanted to just convert to radians totally, I would just take pi radians and subtract. I'd clear it first. I'd take pi radians and subtract 0.666, and that's not what I get. Pi minus, see, something funky with this calculator. Still something funky. It's the C. I got to find not press this C and press something else. And there we go. I got to press this one. Okay, I'm going to take pi and subtract 0.66, and I get 2.47, which is not in pi. So if I divide that by pi, I'm going to get it in pies. 0.7878 pi. So that would be one of the things. So let's see if this first one comes out to 0.7878 pi. All I do for this first one is divide 38.21. Oh no, sorry, the first angle is 141. So I take 141.786789, and I divide it by 180, and that will give me the pi radians. Yep, same thing. So either step works, and you can practice either way. So principal angle 1. Yeah, copied the wrong thing. Copy principal angle 1. That's how many pi radians. Angle 1. So there's got to be a pi at the end of it. So just do that and say pi radians. And principal angle 2 is 218 divided by. So all I'm doing is finding the two angles in radians. That's all I'm doing. Divide by pi. Sorry, not divide by pi. Divide by 180. And I get 1.21223. So I'm going to copy that, select all. And angle 2. If I make a typo, just ignore it. And that is also not correct. See, it's not copying over the thing. Copy. And I'll just round that up here to 7. And that's also in pi radians because I didn't, again, multiply by pi. I just left it in pi. Had I multiplied by pi, I'd get a numeric radians. So to explain that, when I take 360 and I want to convert it to pi radians, you're supposed to divide by 180 and then that would become 2, and I would multiply that by pi, and I get 6.28. But I don't want this decimal, I just want this. So after I've done this part of it, I don't multiply by pi, I just put the pi right in front. And that lets me know, yes, I'm supposed to multiply by pi, but I'm keeping it in pi radians because later on it's going to divide out. So you just essentially convert the degrees into a fraction and know that it's going to be multiplying pi. But you can just express it as this number times pi radians. It's always good to just keep pi in there if you know it's going to come out. But the point is I figured out the two angles. And they're in quadrant 2 and quadrant 3. And that's at this point that you bring this back and you make it equal to this equation. And we're trying to figure out what d is equal to. D is equal to. So obviously, as we discussed, you multiply by the reciprocal on both sides to get rid of it. And that is why you kept the pi out here, because these pi's cancel. Okay, so it's just a matter of this times that divided by that, or this divided by that times that. Doesn't matter what order you go in when you're multiplying and dividing. And the first day that we get is 143. So the day equals 143 when air conditioning is turned on. And the second one we get is the same process. You now make, and I'll just bring this back so that I still have a sample. You now make this one equal to this on the right. Because now we're just working with the angles inside. We're just working with the angle inside. We're trying to take this angle and convert it to the days. So the same thing, you multiply by 365 over 2 pi to get rid of this multiplier. Cancels out. And which means you have to multiply the left side by the same thing. So it essentially just cancels out on the left. On the right, rather. And you just take the 365 divided by 2 and multiply it by the 1.2 1.212295617. Always good to just keep your numbers in your calculator. And this is the other one you get. Day air conditioners get turned off. Okay, and also keep in mind that these pi's cancel out on the other side. That's why we left pi in there. Okay, and if you need more clear information about how I get this into pi radians and just leave the pi in there, if you look at your conversion, it's clear, but just practice with a few of them and you'll realize. So we have our 2 days. Now the only concern is if your teacher wants you to convert those into like May 20th and July 27th, and then you'll have to do some little calculations knowing that January 1st is equal to day 1, as said right here. But generally, this is good enough. And sure enough, if we graph it, we will indeed see a cosine curve that starts way down here, goes up, comes up, and if we were to draw a line y is equal to 32, which is the temperature they're looking for, we'll discover that it indeed crosses the line right here at 143.75, 32, and then again over here at 221.24, 32, and that's because the temperature rises and comes back down. That's why also there's almost always 2 temperatures unless it crosses through the very top, because it'll cross no matter what line I draw, straight line, straight horizontal line, I'm crossing a sine curve or cosine curve twice. So there's always 2 angles. It makes more sense when you're doing that. So I'm going to look at the easier questions now. And I have a whole bunch of samples I'm going to send you. And these are exact value questions. exact value questions. So for this, you should pull up your exact trigonomic value tables. Exact trig values. You can always Google them too. And then just click image, and you'll always get a nice, they'll usually give both versions. Remember that one is with the denominator rationalized, meaning they don't like the square root at the bottom. Fortunately, this question's like that too. So first, always note, they're talking about a full circle. How many solutions are possible? Probably 2, unless that's a peak. Which quadrants would you find the solution? Well, sine is positive. So let's start with that. Where is sine positive? Well, according to CAST, sine is positive here, quadrant 1, and here, quadrant 2. It's not positive there. So we're talking about quadrant 1, quadrant 2. That's the answer here, right away. Then you would just say, okay, when is sine of x square root 3 over 2? So we're looking for the acute angle. And if we look at our chart, sure enough, there it is right there. Sine is this. Sine of 60 is that. It's right there. And work on your triangles to get that. So that means we're talking about an acute angle of 60 degrees. Okay? Keep in mind, your teacher's always talking in pi's. 60 degrees is the same as 180 divided by 3, so it's pi divided by 3. However, we're talking about an acute angle, so we're talking about this one, which is in quadrant 1, and we're also talking about this one, which is in quadrant 2. So this one you can either calculate as 180 minus this acute angle, which is probably the best way to do it. Now 180 is pi, so you've got pi minus pi over 3. How do you put pi over 1 over pi over 3? You multiply by 3 over 3. What's 3 pi over 3 minus 1 pi over 3? It's 2 pi over 3. So that's the second angle. That's called the principal angle. It goes all the way to there, and the first principal angle is the same as the acute angle. So my two possible answers are pi over 3 and 2 pi over 3. Those are the two angles. Remember, the radians are just another way of expressing angles. Determine the related acute angle for the equation. Well, we had to already. It's pi over 3. It's 60 degrees. That's also, you could be expressing if you wanted degrees as 60 degrees, but that's it in pi. Determine all the solutions for the equations. We did it. How many solutions are possible? As I said, 2, because sine is positive in 2 quadrants. Not that hard, that one. Okay. This one is a bit weird. You want to make sure you know what your teacher's asking. But roots equations, the root equation for a quadratic is x minus and x plus. It's whatever makes a 0 in there. So when they tell you the roots are 6, they're telling you that it's 6 comma 0 where it crosses the x-axis. So it's 6x where y is 0. And they're telling you the other root is at minus 7. Well, what's interesting is, and actually, you know what? Let me make sure that, because I think the roots are the actual values. Roots of parabola. So let's see. Yeah, the roots are the actual x-intercepts. Yeah, 2 real roots. So let's just make sure. Yeah. So I'm almost certain root in factored form, yeah. I'm almost certain the roots tell you the actual x values. So to find those roots, you actually have to do the reverse up here. X minus 6. And this tells you that when x is 6, y is 0. And when x is minus 7, y is 0. Now, I'm almost certain of that. I should actually make sure that I'm pretty sure that when they tell you the roots, they're actually telling you the x-intercepts. And let me just do a Google search. I'm 99% sure. Are roots the x-intercepts? Oh, that's that's it.
Grammarly is an amazing tool that can be downloaded.
Do that. Just want to get the images. Over here. Now I think I've got it reverse. Yeah. Oh, I might get back to you on that. So if you have a clear remembrance, I remember the roots being told as being the actual x-intercept values, but it could be that I've got it backwards. I'm going to actually, you know what? The more I think of it, the more I think I have it backwards. So if those are the roots, if they're saying plus 6x minus 7, you also have to put an a in front of there. And I'll clarify that later. Because you don't know if this has been stretched at all. But if it's just without stretch, that's the factored form. Y is equal to x plus 6 and x minus 7. And that is because when x is minus 6, this becomes 0, so y would be 0. And if x was positive 7, y is equal to 7. Notice that the x-intercepts are the opposite of the roots. And I believe I got it right now. If you multiply both sides of the equation this way by 3, nothing happens. And that's because this, you want your y alone, and you end up dividing it by 3 later, and it's gone. If you multiply it by 3 when it equals to 0 up here, all you're doing is keeping the x-intercepts the same, but your parabola is getting stretched. So it depends what he means by that, and that's why I hesitated. So I got to clear up the roots, and I'll have an answer for you soon. I used to know it so well now. It's just kind of fading. No, that is not the page I'm going after. All right. These are just quadratic formulas. And I'm surprised you have them in there. But if you just look at it, you never want a negative in front. So we'll start with this one. So obviously this is equal to 0, so we're finding the roots, essentially. If I factor out negative 1, I'm left with x squared plus 10x plus 16. And now all we have to do is factor this to figure out when it will equal to 0. So what number multiplying out is equal to 16? That adds up to 10. Well, that's 8 and 2. And since they're both positive, it's an easy one. So now I can replace all of that with minus 1, x plus 2, x plus 8. And if in doubt, multiply it out, distribute it, and confirm that it's that. So right there, from that, the answer is actually the opposite. X is equal to minus 2, and x is equal to minus 8 in order for the equation to equal 0. So notice that the x's have to be the opposite in order for this to be true. Because it makes sense, because the only way this can become 0 is if this is the opposite of that. All right, so that's a pretty easy one. The second one, you have to just remember that you always want to see if you can get the front value down to with no coefficient. And look, they're all divisible by 3. So when I factor out 3, I'm left with t squared plus 8. Bring that back in a second. Plus 8t plus 15. And that makes it a little bit easier. It's always easier to factor something that does not have a thing in the front, coefficient. So now all we have to do is do our factoring and say what number multiplies out to equal 15, positive, and positive 8. And that's very quickly 5 and 3. So we can immediately replace our thing here with the factored form. 3, t plus 3, t plus 5 is the only way it works. Therefore, t is equal to minus 3, and or t is equal to minus 5 in order for the equation to be true. And that's the only possible values of t where this equation will work. That's what factoring is. And if you were to turn this into a parabola instead of the 0, you would realize by setting it to 0, all you've actually found are where it crosses the x-axis. It crosses the x-axis here at minus 3 and at minus 5. It's an upward facing parabola, so it's going to look something like this. It's going to go through the x-axis, come back up, and its its vertex is going to be halfway between minus 3 and minus 5. It's at minus 4. I could even plug that in and get the vertex, or I could remember my trick and make minus 24 divided by 2a, 6. And then, oh, well, there, that's giving me, that confirms that my vertex is minus 4, and then I'd still have to plug it in. 16 times 3, 48, plus, or minus 96. So I get minus 48 plus 45. I believe it's minus 3. I think it's minus 3 down there. So there you go. Those aren't very hard compared to the first question. I'm going to jump to these because these are the same. They're just got to be rearranged. Okay. So how do you figure this out? Well, you get it all to the other side so that it equals 0. So to get these to the other side, I'll do it step by step. I add 6 to both sides. So I've got to add 6. And those cancel out. I add plus 7m to both sides. So this is plus 7m. These cancel out, and I'm left with 0 on the right side. So writing it a little bit easier, I'm just going to take this equal sign and move it over here. I'm going to get rid of that, and I'm just going to turn this to plus and plus 0. And so they all went to the other side of the equation. Now all I have to see is look at the 2 and the 6. And can 2 be factored out? No. So I'm going to ask myself 2 times positive 6, because remember they stayed positive, is 12, and 7. Does anything multiply out to 12 and add up to plus 7? Yeah, 4 and 3. Now this is my slip and slide method, but if you don't like it, use factor by grouping. So what I do, since we're dealing with m, I do m plus 4, m plus 3, and I always make sure it's right at the end. And then you take the factor out in front, and you divide each of the things you found by it. And if it can be divided, as in this case the 4 can be divided by 2, and it becomes 2, great. Just simplify it. If it cannot be divided, which is the case here, this is where the slip and slide comes in. The 2 goes up here. Now just to make sure I have the right factors, m times 2m is 2m squared. m times 3 is 3m plus 4m, that's plus 7m. And then plus 6, so those must be the right factors. 2m plus 3 and m plus 3 plus 2. And then to figure out when they are 0, I set the whole thing equal to 0. Well, it's when either of these brackets becomes 0. So when does m plus 2 equal to 0? When m is minus 2. And this one's trickier. When does 2m plus 3 equal 0? Well, subtract the 3. When 2m is equal to minus 3, then divide by 2. When m is equal to minus 3 over 2. And if you plug either of these into the brackets, you will discover that they become 0, and if they don't, you did something wrong. But notice that this was the first root we found when I said divided by 2. So this is just the flatline version of not having a factor in there. M plus 3 over 2 would give us the same factor, it just wouldn't expand nicely. Still might expand nicely, but anyway, no, it won't. So there we go. So that's just factoring. The next one's no different. You just get everything to one side of the equation. So I'm going to subtract x. And then I'm going to subtract 8. And I'm left with equals to 0. So now I got to factor it. So what's 9 times 8? Well, the answer is going to be right in the factors, actually. 9 times 8 is 72. And what numbers can multiply, negative 72, by the way, 9 times negative 8. And what numbers can add up to plus 1 in that situation? Well, it's plus 9. It's the same factors, plus 9 and minus 8. Both add up. Oh, we've got to have minus 1, not plus 1. So it's minus 9 and plus 8. Both add up to minus 1 and multiply out to minus 72. Now, using my slip and slide method, that becomes x minus 9 and x plus 8, and then you take the factor that's in front, the 9, and you slide under this, and you slide it under that. And if they can be divided, great. Turn them into the whole number, x minus 1. And in this case, this right one cannot be divided, so that's where the slide comes in. Take the 9 and slide it in front of the x. And always make sure you got the same right factors, because sometimes this slip slide method doesn't work perfectly. I forget the conditions where it doesn't. But 9x squared, yep. Plus 8x, yep. Minus 9x, yep, makes minus x. And then finally, what was this? Minus 1, yeah. Minus 8, yeah. So that means for this to be equal to 0, x has to be equal to 1, or x has to be minus 8 over 9. How did I figure that out so quickly? Well, I set that to equal 0, subtracted the 8, divided by 9. You can just sort of visually see the opposite in there. And so when x is minus 8 over 9 or x is 1, this whole thing, or this whole thing, will be true. You can see that just by making it a number, it gets you confused until you make it equal to 0. Then it's solvable. Second one, last one's the same thing. How do I get that all equal to 0? Well, I got to add 9 to both sides. On the right side, it becomes 0. On the left side, it becomes plus 9. It's equal to 0. And it's the same process. I have to multiply the 4 and the 9 to realize I'm seeking for a number that multiplies out to 36 but adds up to minus 12. A little tougher. We're looking for numbers that are sort of in the middle, like 6 and 6. And sure enough, there it is. Minus 6 times minus 6 will make plus 36, or it'll make minus 12. Add up to minus 12. So then I do my slip and slide. X minus 6, sorry, y minus 6, because we're dealing with y now for some mysterious reason. Minus 6, then I take my 4, and here's where it gets, I think here's where it gets tricky. I believe you have to simplify to 3 over 2 first. You have to simplify it as much as it will simplify in the slip and slide method. Go back and review factor by grouping if you don't like the slip and slide method. Now that it can't be simplified, the 2 slides up to here. So I get the same factors. 2y minus 3, 2y minus 3, or 2y minus 3 squared. But let's make sure. If I multiply 2y times 2y, I get 4y squared. That's why it had to be simplified. Minus 6y minus 6y, that's minus 12y, and plus 9. So yes, you must simplify your fractions before you slip and slide them. Otherwise, you get much more larger factors here. So that's the answer. And what's the only possible answer for this to be equal to 0? Well, when one of these brackets is equal to 0. So when y is equal to 3 divided by 2. How did I do that? I made 2y minus 3 equals 0. I added 3 to both sides, divided by 2 on both sides. So that is the only answer for this to be true. Almost done. And your last question is slightly difficult, but not really. It just makes it look like it's difficult. Okay. The first step here is to realize this is still a factoring. It just doesn't look like it. You got 2 cos squared and cos. And just remember that 2 cos squared is really cos of theta, or x, squared, plus cos x plus minus 1. Well, think about it. If instead of writing it like this, let's for 10 seconds make x is equal to cos x. and replace everywhere I see cos x with x. So I get 2x squared plus x, 1x, minus 1 equals 0. So now that's an easy factoring. I have to find a number that multiplies out to minus 2 and adds up to plus 1. Well, that's plus 2 and minus 1. That's the only thing that multiplies out to minus 2 and adds up to plus 1. So these are the factors. Now if I use slip and slide, I get x plus 2, x minus 1, and then I got to take this 2 and divide both numbers by 2. 2 divided by 2, that's 1. So that's 1 there. And negative 1 divided by 2 can't be simplified, so it has to slip and slide in front. So I get x plus 1 and 2x minus 1. And just to make sure, expand them, is equal to 0. Just to make sure, expand them, you get 2x squared minus 1x plus, oh, that should just be a 1 here. So you can see I made a mistake. All right, 2x squared minus x plus 2x, that gives plus 1x minus 1. Great. Now, if either of these things is equal to 0, it works. So we can keep going on this or replace it, but I'm going to keep going. So that means from this, when x is equal to minus 1, or when x is equal to 1/2, this is true, right? Because a half here makes this 0, and minus 1 here makes this 0. At this point, we're going to come back and replace the x with minus 1 here, cos x. So when cos x is equal to half, or when cos x is equal to minus 1. Well, I happen to know from experience there's only one situation where cos x is minus 1, and that's the unit circle. Yeah, you remember if we go around the unit circle, the x, y values are cos comma sine. The first one's 1 comma 0, the second one's 0 comma 1, the next one's minus 1 comma 0, and the next one down here is minus 1, 0 comma minus 1. Well, if you look at cos, it's the first x value of each of those. And where is it minus 1? Only one spot, right over there. Since he's looking for pi radians and he's talking about 360 degrees, he's talking about 180 degrees or 1 pi. So the only way this is true, the only way this one's true is right there, 1 pi. So right away we know that the only way that this equation is true is when theta, one of the solutions is that theta has to be equal to 2 pi. And sure enough, if you put it into this equation, it'll all, as 2 pi, it'll all come out to 0. So that's that one. What about this one? Okay, well, that's interesting, and for that you have to go back to your knowledge of cos right there. 60 degrees, 60 degrees. So pi over 3 is 60 degrees is cos of a half. 60 degrees. So the only way cos x can be equal to this is when this is 60 degrees, or pi over 3. Well, the problem is this is positive, and cos is positive here and here. In this area, quadrant 4 and quadrant 1. So that means our first answer is that. That's the acute angle that also is the principal angle right there. So theta is also equal to pi over 3. That's good. But this other angle down here is also pi over 3, and cosine is also positive. And that's 360 minus pi over 3. Well, 360 is 2 pi. So what's 2 pi minus pi over 3? Well, you got to convert this to something over 3. So you got to multiply by 3 over 3. You get 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. So the third and final angle that is possible is theta is equal to 5 pi divided by 3. So those are the three possible angles. Notice that there were three possible angles because we had roots, which creates two roots, but also one of the roots has two possible angles. It's possible to have four possible angles in a root question. Just so happened that one of them only had one solution right there. This one could have easily had two. So that's very simple. You treat it like a factored x. Then you solve for x, and then you replace the x back with what you started with, and then you find the possible angles using your knowledge of cast. This one's the same. It's the exact same. You start by making x equal to sine. X is equal to sine theta. So now you have 2x squared, and then you get all the stuff on one side. Plus x minus 1 is equal to 0. And just remember that this is squared here. And so now you must factor that. So you have to say what multiplies out to minus 2, but adds up to plus 1. Well, that's plus 2 and minus 1. It's the only one that works. So now you factor that. You use the slip and slide method. So you get x plus 2 and x minus 1. But remember the slip and slide. You now have to take this 2 and divide them both by it. That's the slip and slide method. This second one cannot be divided by 2, so it slides on up. And this one can, and it just becomes 1. Just becomes 1. Let's see if I can do that again. There we go. Nope. Last chance. 1 plus 1. Good. Then you can solve, so you got 2x minus 1, just in case you forget. Pardon me. Then you solve it. So when x is minus 1, this is true. And when x is 1 over 2, this is true. So very similar answers. Now you go back and you bring back sine theta for x, and you solve for this. And again, it's very similar. You go back to your unit circle and realize that the top one only has one answer. When is sine minus 1? Well, when the y value is minus 1, that's over here. So over here, that's sine value is 0. Over here, sine value is 1. Over here, sine value is 0. And then down here, what is that? That's 1 pi to here and a half pi. So 3 pi over 2 is one possible theta. You just get used to that being 270 degrees. Okay, well, that solves that one. This is very similar. When it's sine equal to half, you go to your thing and you look at your second value, and sure enough, it's when the angle's 30 degrees, or pi over 6. So that means when it's pi over 6, that's the angle that produces a half. However, pi over exists, let's look at this as positive. Positive signs exist in quadrant 1 and quadrant 2, according to cast. So only here. So that means we're dealing with the acute angle, the actual angle. So pi over 6 is one of the answers. And then the second angle exists over here, in which we have to take 180 and subtract pi over 6. Well, 180 is pi. We need to convert that to 6 over 6. So that's 6 pi over 6 minus 1 pi over 6. So finally you get 5 pi over 6 is the other principal angle that stretches all the way over here, which is the same as 180 minus 30, 150 degrees. So this is 30 degrees, this is 150 degrees, and that is 270 degrees. But they're all angles. They're just expressed in radians. 3 pi over 2 radians, pi over 6 radians, and 5 pi over 6 radians. So those are the three possible angles for this equation to be true. There you go. Hope that helped. I'm going to do some more complicated sinusoidal curves on the next video, but I don't have time right now, and they will be on your test. Teachers love them.